Hello everyone, homework 3, problem 22. So it says this function is not one-to-one. I gave counterexample. If we take integers 3, 0, it gives our output of 6. And if we take 0 and 2, it also gives 6, but 3, 0, not equal to 2. So it's not one-to-one. And it's also not onto because major natural numbers are missing. If we take the smallest 1, it gives only 5. So 1, 2, 3, 4, and other many natural numbers are missing. So B part, um, this function is also not one-to-one. I gave here counterexample, and it is onto because if we construct like function uh, by taking any integer, we can get in output every integer. So every integer is achievable. Part C, here it is also not one-to-one. I gave counterexample why it is not one-to-one. And it is not onto because if we take the smallest values of 1 and 1 of n and m, it gives 36. So it means that 36 is the smallest value, but it must be starting from 1 to infinity. So it also skips too many natural numbers. The part D, it is not one-to-one also. I gave here counterexample. And it is onto because the greatest common divisor is 1. And when the greatest common divisor is 1, so we can achieve every integer. So it is onto. Part E, it is also not one-to-one. I give here counterexample. And it is not onto because some natural numbers like 4 and other numbers are missing. So they are not in range of this function. Function f, here it is also not one-to-one. I gave here counterexample also why it is not one-to-one. And it is onto because I constructed the function. If we take this original function and the output is k, so when we transpose 1 to right side and take m as a 1, so this function, by putting any number like as we want, we can achieve any natural number. So it is onto. The problem 29, here it gives two functions, and in A it says to find one-to-one functions. So by formula, it says like it has 24 one-to-one functions. So here's the list of all of them. And the second part of this A part is from y to x. It doesn't have functions because one-to-one functions because y cardinality is equals to 4 and x cardinality is equals to 3. So at least two elements in y function will match same element in x, so there will be no unique pairs. The part B, here it says to find onto functions. So from x to y, it doesn't have any function because it is impossible to cover all 4 elements of y with 3 elements of x. From y to x, it has 36 onto functions. By formula, I found this. And other part B, I gave an example of one-to-one function, but not onto function, and that doesn't contradict the uh, the A part. So here I explained why it is one-to-one and why it is not onto, and why it does contradicts. It doesn't contradict because natural numbers are infinite, and if we turn here, it is finite series. So this theorem doesn't match to this one. And also C part, I found the function that is not one-to-one but onto. So it also doesn't contradict because natural numbers are infinite. So thank you for attention. That's all.